Okay, let me clear some. Okay, so this is a casual revision. Okay, for those of you who are sitting down, comfortable now, okay, please help to answer. But if you're still driving or you're still managing something, it's fine. Just tell me that you cannot interact right now. I understand. Okay, so this is for us to revise back. Okay, so this happens during 2008, the death of this quite famous singer. I was in UK in 2008 when this happened. So now, let's say, okay, because we are doing revision before we proceed to the statistic part, you are called to the site. You are called to the site to as a chemist, yeah, as investigating chemist. You're not there as a policeman, policewoman, but you are there as a investigating chemist or whatever that you want to call it. And then this is what you need to do. You are the one who's in charge. All right. Okay, you're not dealing with the body, but somehow, I mean, you're not the pathologist, but you still need to do some sampling. Okay, so now imagine yourself, it is there. So I'll go for a few people first to ask. Okay, so Hidayah, what will be the first thing that you need to decide once you are at the site or before you are at the site? It means that you are traveling, you get the assignment. What is the first thing that you think that you should do? Hidayah.
Okay. Hi.
Mhm.
So I think on the way there, I would think how would I do sampling? I mean
Okay.
like how or what method? Oh no, I'm sorry. What sample should I take to determine M is there?
Okay, before you decide on the sample, because the
Hmm?
sample is related to the method, right?
Okay.
Okay. So whether you should decide on the method or you should decide whether you should decide on the sample or you should decide on the method first.
Hmm. Sample first.
Sample first, yeah? Because the sample determined by the methods. Okay.
Yeah.
All right. So according to the typical lab analysis or analytical chemistry procedures, you have to, of course, have some hint. Yeah, have some hint first. Um, Usually, when you get the report or when you get a call, there is a possibility that this is due to overdose because you need to have some hunch first, some hint what to do because it's not just blindly picking up the sample. All right, and then once you know it's possibly of drug abuse, overdose, right? You know already what you need to decide what method to do to analyze because to do the analysis because depends on your lab. Some lab, as I mentioned before in the last class, if you have LCMS, you are blessed. I hope that everybody know what is LCMS. It's liquid chromatography mass spec, one of the robust analytical methods. So if you have that in your lab, then you are blessed. I mean, you can do things, a lot of things, especially if you are to uh, analyze drug. Okay, you need to know the amount, what kind of drug, because it is suspected that it is overdose, drug overdose. So now you have at least some idea the method that you want to use. If you don't have LCMS, at least you have HPLC or you have GC back um, in the lab that you can use. And also, since this is a high profile case, this is a high profile case, of course, you need to do it as soon as possible because people will chase you. They need to know what the cause of death and all that. So this is a high profile case. It's not like a routine case that you do. So you need to think about a very fast method. Okay. Now, Sajita.
Yes, Prof.
Yeah. Okay. Now you already knew what is in the lab, and possibly you are to use chromatography for the methodology. So can you what's next? What's next? What's next to do?
Okay, perhaps after the method, I may work on how to perform the sampling,
Yeah.
what kind of samples to be taken, how long is to be kept, if there is any preservation needed,
Yeah.
and also the surrounding area to ensure I take a representative sample, perhaps.
Okay. All right. So thank you, Hidayah and Sajita. Okay, of course, I'm sure those are we discussed last week. You need to know about the method as well as the sampling. So as I mentioned, sampling is not covered in the subject. So it's good for you to know if, let's say, you want to do a master dissertation on analysis of water sample, for example, from industry, from river, then you need to know how to sample. Okay, my question to Valerie, let's say, okay, why do you need a proper technique in sampling?
To avoid contamination.
Okay, a contamination, one factor. Other than that?
To make sure it's not I don't know how to construct the sentence.
It's
To make sure
okay.
it's isolated. Is that the right word?
Preserve,
I think.
yeah. All right.
Uh,
Okay. Yeah, okay, good. One is, of course, we do not want to be contamination, and we need to have a proper, as Sajita mentioned just now, preserve. Yeah, how to preserve it. But I think as a investigating chemist, you are well trained, and usually, if you know that these forensic people, they have in their boots, car boot, usually a series of vials, containers that already contain preservative. Yeah. So, but as a chemist as well, you need to know what kind of samples that you want to take from the body. Probably not from the body. Usually, the body we don't touch. Okay. The pathology will do that for you. They bring back and then cut whatever from the bodies. But still, you as a investigating chemist has to do some scouting in the crime area, looking for the possible uh, containers, looking in the toilet. So whatever that you think, the samples that suits to be analyzed. So those requires you to think. Yeah, you need to think because somehow you are in a house of somebody that you don't know. You still has to look at, okay, their drug cabinets, you look at their fridge, the foods that they take, the drinks, so the table there where they dine, where they sit in. You have to look at all the samples. And to Valerie, okay, yes, of course, to reduce contamination, and imagine the samples, okay, needs to be taken back to the lab because most of the time you don't have a very accurate on-site analysis. You have to take back and then remember that you need to preserve as well as whether the samples is suitable for the method that you have chosen. So that's why the method is very important to be decided first, and then you sample it, suits the methods that you decide, and then you bring it back. Okay, next step. Farah, Nurul Farah.
Yes.
Yes, Farah, what is the next step?
Prepare for analysis sample
Yes, yeah.
to for analysis.
Sample treatment, yeah? Oh, yeah. Okay. So it's very crucial for this kind of, for this kind of cases, or if you have like a very high profile case, you need to take back the samples immediately. You cannot afford to stop anywhere, because if it happens that people know you breached the procedure, you might be challenged in the courts. Okay, so remember, there is a case in Malaysia that the brother of president of North Korea, the younger brother, right, is killed at Malaysian airport. And it was, I think the final report is due to some toxic substance that they put in the in the face of the North Korean president's brother. So imagine that, how to conclude that if you don't have the samples, a good analysis, and this is a very high profile case involving North Korea, then you must be careful. Okay, it's not like saying that the routine analysis is not important, but you have to imagine how bad it is, the situation. So we need to bring back the samples and do a pre-treatment. Okay, so you need to have knowledge on the sample preservation. You cannot just put it on the shelf without proper temperature control, or the samples will be degraded in just one day. So you have no chance but to do the sample prep, and so do the measurement there and then. Depends on the possibility of the degradation of the samples, or degradation of the chemical components that you want to analyze. Okay, so if it is stable, then you are safe. If it is not stable, then you have to take overtime to do it. Okay, and next one. Okay, once you have prepared, when you have pre-treat, do the crushing, do the sieving, do the dilution, do digestion if it is needed. Okay, what's next? Okay, Lily, what's next? What is the next step? You have pre-treated your sample now. Lily?
Yeah, doctor.
Yeah, what do you think is the next step?
We should use measurements method to analyze the data.
We have to measure first to get the data, right? Once you have pre-treated the samples, then of course, we have to measure. Okay, so now you decide on chromatography just now, so you do the chromatography techniques. Okay, just one point that I would like to remind everybody. At this stage, replication is very important. Replication. Okay, so why SD? Is the replication is very important? Is the?
Yes, doctor.
Why is replication during measurement is important?
Because for the replications, we can we can differentiate the data, and also we can validate the analysis.
Okay, so your first answer just now. Second is validate. Second is the first. I missed that. Hello.
First, we can differentiate the data if we have
Okay.
replications.
and then validates. Okay. All right. So thank you, SD. Okay. So when you do pre-treatment, okay, means that you start to process the samples, you have to think about the replicates. Replicates means that you have to do the same setup of protocols, but from different set of samples. Okay, the samples, yeah, easy to say. If you have the same sample A, you have to at least divide by 3 and then do the same analysis towards this 1, 2, 3 samples. Minimum of 3 replicates. Okay, so I hope that this is very important. I hope that you all of you understand, because during your master dissertation, if you want to do especially wet chemistry, please prepare the samples in replicates, because in future, if you are to do statistical analysis, you have to do a minimum of 3 or 5 samples. Okay, now, so this is what we discussed just now. Okay, because before we can achieve the data, that is the process that we need to do. So define the problem is, as a chemist, you already knew some significant information from the crime scene, that it is a possibility of drug overdose. So of course, you need to have some ideas what to do, what method to apply, and then you start to this is some analysis that you have to do before you can decide on the method, how fast, okay, whether okay, this is of course a very important. You need to you want to analyze the drug, because there is a big possibility is drug overdose. So when, how fast, budget means that your lab does have a very good technique, so it's fine. Who will use the information? Also, sometimes it is very important, because are you going to submit to a very technical person, or are you going to submit to a layman? Okay, so this one goes to how detailed the analysis will be. Okay, right. So this is some answers, possible answers to that. You want to find out the metabolism products of the drugs. This is the one that you wish to submit, the forensic chemist. You are just the investigating chemist, because it is a high profile case and you need to submit the results ASAP, as soon as possible. So what method? Usually the best is chromatography. And of course, it's going to be a very costly, all right? Because you have to do it fast, and then you have to do it using a good technique. Okay, next one. Okay, and then of course, as I mentioned just now, before you decide on the sample, you have to decide the method. But this goes concurrently. You define the problem, you already have ideas on the method, and now you start to do the sample. Okay, and then we come to sample preparation, or what to do, whether you need to talk to all these people, some biologists, some pharmacists, toxicologists, okay? And of course, just now I mentioned about sample preparation, whether you need to dissolve it, filter, pre-concentrate, purify, or whatever, depends on the method that you have chosen. Okay, right. This one we have discussed just now. Okay. Right. Okay. So now you have the data. So this is where actually the subject comes in. You have the data. So once you have performed the measurements, since this is quantitative, if you're using a high-end instrument, everything is calculated for you, so you don't have to worry about constructing calibration plot or whatever, because the data will be generated from the machines. But validation is very important. Okay, so somebody mentioned about validation just now, and ISD talk about replicates, and this is very important to make sure that you have enough samples to do replicates, because without replicates, there's a lot of error. So that's where we are going to after this, is to talk about error first, and then going towards statistics. Okay. All right. Of course, the statistic is this. I mean, this is a step when we involve the statistic, whether we can get useful information from the data, or we might not get. We have to repeat again the analysis. Okay. Like we have blunders. Blunders means that we look at the result, totally cannot be used. So definitely we have to repeat. We might have to repeat some part, or we might have to repeat a lot. I mean, like all the analysis. So that's things that we need to think about when we prepare the samples, because you might have to repeat everything. Depends on the analysis that you do, analysis of results. Okay, I'm not going to talk about samplings again, all right? So you must remember the samples must be representative, very important. And then you have different types of samples. You might have gas, you might have solids, you might have liquid. So you have to handle that, right? Sorry. So these are some examples. Okay, so I'm not going to talk about significant figures. These are common things, and you have learned about significant figures. So I just skip this one, all right? Okay, so let's talk about precision a bit and accuracy. So when we obtain data, okay, it's very crucial that you have these both characteristic. Yeah, precision is easy. We can view from this diagram that the data that we obtain should be close to each other. Means that this is the analysis that we do. The data is close to each other. The value means, okay. So accuracy, okay. This is, I mean, everybody should know this, that this is the standard material, for example, or the standard value, or the true value. Okay, we learn it in t-test. Okay, so how close the data that we analyze with the standard material value, for example, or standard value, or true value, or certified value. Okay, so this is accuracy. And of course, our main target is to have this both, yeah, in analysis. Highly accurate and with high precision. So this is I believe this is a revision, so no need to worry about this. Okay, so errors. So I'm sure that if you remember the process, okay, starting from you picking up the samples, storage, and then do sample pretreatment, sample storage again in the lab, and do the analysis, you have a lot of errors and uncertainties. Okay, so we're not going to discuss complex errors. So we just have to know some possible errors that can happen. There is a big issue. This is what we call as systematic or determinate errors. Means that you can identify the magnitude of this kind of error remain constant, and this kind of error is reproducible. Means that you can actually avoid this error by doing some countermeasures. Okay, so instrumental error. Okay, one is, of course, we can do that by proper maintenance of the machines. Okay, we can avoid this. We know machines have limitations and they require maintenance. So if you do it well, the maintenance, the validation, the verification, or anything that requires by the maintenance by the supplier, then it should be no issue. Unless the instrument is broken and it's not properly managed, then you have instrumental error. Okay, let's talk about this. There's something else. Where is it? Oh, it's not in the. Okay, there is one more error. Okay, the second one is human error. Human error, we don't say human error, we say operator's error. But now, as we have machines like auto samplers, so this kind of errors probably does not come from the operating the machines, but comes from the sample preparations. Okay, so you can also avoid this error by a good training. Okay, and other than that is by doing some validation. Okay, between the labs. Okay, so that's why sometimes when we do analysis, let's say in lab 1, in order to confirm the data is somehow acceptable, we can send the same samples to other lab. Okay, do the same analysis or do different methods, and then look at the results, whether we get almost the same or we don't have a similar results. And then that has to be, something has to be done if there is a discrepancy between lab 1 and lab 2 for the same samples, but different results, totally like a different results, or there is a significant difference in the results. So something has to be done. Okay, so the third one, it is not in the slide, is the method error. Okay, we have Atika. Atika, what is an example of method error? It's not human, it's not instruments.
The method is not suitable for the sample.
Yeah, can
Meaning
you?
that
Yes,
Ah,
continue.
so, for example, in case I have a solid sample, and then I would like to conduct FTIR, but the type of pellet I use is not suitable for testing the solid sample. It is between ATR and KBR pellet, for example. Okay.
Okay, all right. So definitely, as a chemist, I mean, this is where you apply your your knowledge, whatever that you have come across, whatever that you have studied before. This is where you put all your knowledge in here. So method error is difficult. Once you have a method error, means that you choose a different, a wrong method, then it's going to be a blunder. Okay. For example, just now we're talking about drugs. Okay. We know that the drug is being consumed by the victim. Okay. But in order to identify the drug, it probably is no longer in original compound. I mean, it is no longer in the original drug. Okay. It is now in a metabolite form. Okay. So you have to search for a correct method to find the metabolite. So you have to know what drug is possibly the main one and what it is going to be the metabolite form. And once you know the metabolite form, then you have to decide. You have to open books, you have to study what method is the correct 1, 2. If you choose the wrong method, you will not find the metabolite, and it will comes to a conclusion that you make a wrong conclusion because you don't find it. You prepare a wrong method and you conclude it is not there. Then your conclusion might be wrong because you have chosen a wrong method. So method error is very crucial because it is based on your knowledge. Instrumental error is quite easy. If you send for proper maintenance, then the machine should be fine. If human, you train them well, and then once a while you validate your data with other labs, then you know that the operator is good, is very efficient because you get the same results. But method error, if you choose a wrong method, you end up with a wrong conclusion. Okay, so very important. All right, so the next error, okay, so those are just now is what we call as systematic or determinate errors, and you can avoid. Okay, you can avoid, you can trace, but this error, the second one, indeterminate errors or random errors, is uncontrolled. Okay, usually it's due to the capability of the machines. You can see here, some balance give you 4 decimals, some balance give you 2 decimal points. So this is what we call as the capacity of the instruments. Okay. So this is unpredicted, cannot be avoided, inevitable, but can be measured or can be treated. Okay, so that's why statistic is very important. Okay, and it will affect the precision. Just now we know what is the precision. Okay, so this kind of error has to be treated by using statistic. Okay. Okay, statistical analysis is to help to counter the indeterminate or random error. All right. So this one, I'm not going to discuss, but this is very, very basic. Okay. So I want, we have another session. It's from 8 to 9. So I will ask questions on these 3 basics. Okay. At least somebody can explain mean, what is mean. Okay. And then what is standard deviation. Okay, so 1 is mean. Okay, because it's very easy, so at least somebody can highlight what is mean. Second one is standard deviation, a basic one. Okay, what is standard deviation, and you can show the formulas. Okay, explain and show the formulas. Okay, and the third one is variance. Okay, variance and standard deviation is very close together. All right. And then we have the next one. Okay. Before we can do the precision test and the accuracy test, we have to do what we call as Q test. Okay. So what is Q test? It's always about rejection of results. It's not rejection of results. It's evaluation of outliers. Yeah, outliers. Okay. So that data outliers. I hope that you can see my writing. Outliers. Okay. So how do we evaluate outliers? Why is it important that we need to consider? Even if we look at the results, we know one or two data is, a bit different from the others. But why do we need to consider that before we throw out or before we keep it? Okay. I think Nawatul. Yeah. How do I pronounce your name? Noah? Are you there?
Yes, Prof.
So why do we need to consider these outliers?
Because we want to get the good linearity on the data. I mean, all the data is close to each other.
Okay, let's say it is close to each other, and then we see one or two that is what we call as outliers, means that it is different from the rest. Okay, can we just throw it away without using any statistical method to evaluate? Why do we need to consider?
No.
Why?
Because we need to see how much is the error between the outliers data and also with the other data.
Okay. All right. Thank you, Nawa. So that's the thing that we need to do first before once you have the data, and then you have considered the data is validated by standard method and then standard reference material, or you have done like validation among the across accredited labs, and this is again you obtain outliers. You need to evaluate first the outliers before you decide to accept or to remove that data. Okay, so this is also very easy. This is all formulations. So I don't know, anyone knows any software that you can just get the Q test done apart from spreadsheet? Anyone? Anyone has experience? I don't have, but anyone has, please do tell us.
Prof, I have no experience as well.
Who's that? Sorry?
No experience, Prof.
No experience. So all this while, anyone has used Q-test?
Yes, but only using Excel.
Okay. So use a spreadsheet. Okay. Oh, fine.
Yes.
All right. All right. Okay. So I think this is quite easy, and the Q-test will answer your question on how to remove or how to exclude or accept the data. So you have to identify the outliers first. Okay, you can see from here. You have to have a sharp eyes. Okay, just look at it, and then you can see that 5.34 is the outlier. So whether you need to remove or accept. Okay, so this is the basic one. So A is the difference between the suspect value from its nearest one. So you can see if there is, okay. So A is 5.34 minus 3.11, the nearest one. And then the range of the values means that is the biggest value. So 5.34 minus the smallest value. So you can see the A over W. The Q obtained is 0.802. Okay. So if you don't get this, it's okay. After this, you can have a look at the question back. It's not that difficult. Yeah, we can see this is the closest value to 5.34. And this is the biggest difference of value compared to 5.34. So this is how you get the Q. So the next step is to use a calculated table, Q table. And how do we identify the Q table? We look at the number of samples. We have 1, 2, 3, 4, 5. Okay. So the number of samples is 5. And we have to look at whether we want to use confidence level. Okay, this is the one that I haven't discussed, confidence level, which I would like one of you to also discuss this during the 8 to 9 session. Okay, so let's say we choose 95% confidence level. Okay, so the Q table, let's say is 0.710. Okay, and then so since the calculated Q is bigger, okay, than the Q from table, which is 0.710. Okay, so there is a significant difference between the outliers just now with the rest of the data. So we have to reject the 5.34 just now. Okay, now it is considered, yes, it has significant difference with the rest of the data, and from the Q test, we can decide that it is can be rejected. Okay, so this is very easy. So for the next 8 to 9, I would like somebody, okay, everybody means that I can ask anybody to just briefly talk about mean. Okay. Number 2 is talk about standard deviation. Okay. The formulas, explain the formulas. Okay. And from actually number 3 is variance, and you can just extend the discussion from standard deviation to variance, but at least somebody has to explain. And one last thing, I need somebody to talk about the confidence level. Okay, so you can share your slides, or you can share your Microsoft MS Word page, or you can just draw, or you can use my slides to explain. Okay, so I need 1, 2, 3, 4 people: mean, standard deviation, variance, and confidence level for me to for the next session 8 to 9. Okay, all right. So I think right before we discuss the F, I think only F for today. All right, any question before we take a break? Okay, so as we have discussed just now, can Zhao explain to us on mean?
Yeah.
You can share whatever that you want to share. You just use share screen. All right, Zali?
Yeah.
All right.
Can you hear me?
Yeah, we can hear you. All right.
Okay. Okay.
Mm.
On the mean of the two or more measurements is their average value.
All right.
And mean, arithmetic mean, and average are samers. And any general data will follow a normal distribution or Gaussian curve, like this graph. And the normal distribution, this is the mean.
Okay, the formula of mean, do you have?
What?
The formula to calculate mean, do you have it on screen? You don't.
And when we
The formula.
Oh, okay.
If you have it, you show it to us. It's very easy.
I have the
Okay. Right. It's okay. Okay. Thank you, Zhao. All right. You can unshare the whatever that you have shared. Okay. My question to everybody. Okay. Let's say, Farah. I think I have asked Farah just now, right? Okay. So, Anybody wish to answer? Okay. So mean, is it related to accuracy or related to precision? Anyone can answer.
Prof, can I try?
Yep, sure.
I think mean is related to accuracy.
Yes.
Yeah.
Yeah. Okay, so mean is of course related to accuracy. So if you look at mean section in the textbook, okay, there are many ways to express it for accuracy. So that's the easiest part. Okay, I will ask you to study by yourself on the accuracy related to mean. It's very easy. Yeah? It's very easy. So those easy things is good for you to um, you just read and study by yourself. The next one is standard deviation. Yeah. Amira Nafisa. I think I put it in the WhatsApp group. So Amira,
Yes, Doctor.
okay.
Let me share my screen first.
Yeah.
But it's been a long time using Zoom.
It's good to practice, Amira.
Yeah.
Okay, you have the share screen button at the
I
bottom.
think it's a download, I think so.
Tak apa. I mean, yeah. Okay.
I think it's yeah. Okay, can you see?
Yeah, we see a lot of your files. You should open the you should open the one that you want to share with us first, and then you share the screen. Okay.
I think I have opened the.
Yeah. Yes. Correct.
Okay.
All right. Okay.
Where is it?
Okay,
Yeah.
the standard deviation. Okay, explain what is standard deviation.
Standard deviation is square roots of variance, which variance is mean average of all data points. So here is the formula for the standard deviation. For this one is used for populations. It's a square root of a sum of x mean value in data, and then this I don't know what the name is. It's called for mean in population, and n is the total number of observation in population. For there's another also S here, but it's used in samples. So basically X, this is for value in data in sample, and then X bar is mean in for sample, and N minus 1 is N is the total number observation in sample. So from what I read, for S standard deviation is used for small database.
And then sigma for more than 30.
Yeah.
Okay.
Population.
All right.
Okay.
Okay, so thank you, Amira. Okay, so my question to everybody again is standard deviation related to accuracy or precision? Anyone? Lily? Precision, yes, very good. Okay, so mean is used to evaluate accuracy because there is a way to evaluate using mean after this, yeah. And then for standard deviation, S and variance as well is used to evaluate the precision. So before this, we have discussed what is accuracy and precision. So it should be clear for you which is which parameter is suitable for which evaluation. Okay, one last one from I keep forgetting the name for the confidence limit, right? Yeah, Atika. Okay, thank you, Atika.
Okay. Hi.
Okay,
So
yeah.
I will just share based on
Right.
based on what Dr. upload in Putabas. So
Mm.
basically, the definition of confidence limits is it show how accurate an estimation of the mean. So moving on to the formula, so we can see that it has mean plus minus with confidence limit. So confidence limit we can obtain from the table, and S is the standard deviation divided by the square root of the number of samples.
Okay.
So I will moving on towards the examples. So examples on page 56. So it given a certain range of value which is from 102 until 106, and it already provided that the mean and standard deviation of those value are 100.5 and 3.27 respectively. So from this question, it asks to find the 95% and 99% confidence limit. So for the 95% confidence limit, we just can key in the data. So first is the mean value plus minus with 2.57. So 2.57 we can obtain from this table A.2 and look at the level of 5 samples and 95%, which is equivalent to 2.57, and then we times by 3.27, which is the standard deviation, and divide by the square root of the sample, and this is the data.
Okay.
So that's
yeah. All right. So now we have the value of mean. Okay. So from the previous presentation just now, we can calculate the mean and then we can calculate the standard deviation. But my question is, how do you get the degree of freedom from the table? How do we decide degree of freedom? Anyone? Atika?
Can it be like n-5 or?
Yes, usually it's n-1. Yeah, degree of freedom.
All right.
Okay.
All
right. Thank you. All right. That is just a very simple sharing. Okay. So let's go to the first test, which is the F test. Let me share the slide. Okay. Right. So the first test that we are going to discuss, okay, I think we will just discuss F test first. So the F test is related to precision, okay, and based on their standard deviation. So just now we know standard deviation formula, and we know also standard deviation is related to precision. Okay, let me. Okay. So in other words, F test is used to determine if two sets of measurements are statistically different. So when based on our discussion just now, why we have different sets of measurement? What does it mean when we have different sets of measurement? Anyone?
Replication?
Replication usually that is not what is meant, but when we do validation, okay, replication is something that during the measurement that is something that we need to be done, and then the data is obtained because when we have replication is the time that we can get standard deviation. If not, then you cannot calculate standard deviation if you only have one measurement. But F-test, okay, when we're talking about validation, okay, just now I mentioned if you are to be sure, you probably need to send to someone's lab to do comparison. So let's say I'm doing an analysis. Of course, replication is compulsory, and I have a set of data. And let's say I analyze the best way, I analyze the drug. Okay, the same sample is sent to another lab. Okay, and analyzed by someone else. Okay, so why? Because we want to make sure that the lab analysis that is done in my lab is consistent, is acceptable, and usually when we send to another labs, usually we compare with accredited labs or probably labs with we know that the results are much better. For example, I sent to CHM. I don't know whether all of you, CHM has this standard lab, so I send a sample to CHM, and at the same time, I do the analysis in my lab. Okay, so in order for me to know whether I have a very good procedures, I have a very good instruments working in my lab, now I'm comparing with someone who do it in CHM. So not necessarily different methods. It can be a different methods. It can be the same methods being used, or it can be like myself, I'm developing a new method and I want to compare with the standard method. It can be that way. Okay, or I'm worried about my chromatography machines, so I run it, and then someone else run the same chromatography technique in another lab. But the samples must be the same. It cannot be different samples. Okay, so when we do F-test, is to check whether there is a significant difference in terms of precision first. Okay, F is usually the first test that we do before the T-test. So the test whether method 1 is more precise than method 2. Okay, we will discuss on the one-tail test and two-tail test later. But first we talk about the formulation. Okay, as you can see is F. Okay, so no issue because it's just the name of the test. And the most important is you already knew what is S. Okay, so F test. S is standard deviation just now. But when you make it into S squared, it is called variance. Yeah. Okay. So the key is when we do a calculation for F has to be more than 1. Okay. The value, because you can see that this is, let's say, method 1 or method 2. Okay. Let's say my lab is considered lab 1 and the other lab that I want to compare is considered lab 2. Okay. I have to rearrange the value. Okay. So that the F value calculated is always more than 1. Okay. So at this moment, you don't know whether S1 will be my lab or S2 will be CHM's lab. Okay. You have to calculate first. You have to make sure the S1 is always greater than the S2. Then you calculate the F. I hope that makes sense. As long as F is greater than 1. Okay, first, that's the rules. Okay, and then the next one. Okay, so of course, we have to do the standard deviation calculation. So now you know that the S1 squared value is bigger than S1, S2 squared value. So we can arrange that in this way. Okay. So if you look at the example, you are developing a new method to measure arsenic concentration, let's say, means that you find a new reagent, okay, that is response linearly to arsenic, okay, and then you do the analysis in paddy rice, okay. After 10 measurements, your method results means that the one that you develop, okay, you get 6.7 plus minus 0.8, means that the standard deviation is 0.8 by your analysis. While old method means that the standard method is not appropriate to use old method, but usually it's a standard method and run, for example, by another lab, CHM, let's say, okay, give you the results of 8.2, which is the mean, okay, and standard deviation plus minus 1.2, okay. So we start by calculating the F, okay. So in order to put which one is on top, which one is as the denominator, so we have to put the 1.2 above, because as the rules is F has to be greater than 1, okay. And then, so this one is by CHM, and this one is my method, my own method. Okay, for the rest of you who do not know CHM is in Malaysia we have what we call as a standard body who do standard analysis. So that's why I put CHM as the example. Okay, so most of the time they are the reference, not all the time, most of the time. Now, so the formula is quite easy, it's S squared. So if you have the standard deviation, then you just square it. And then once we arrange it correctly, so this is the value of F. So now, then look at the table F test. And let's say we want to have it, the analysis at 95% confidence level, then we have to, this is, I don't know whether you are very familiar with this table or not. Okay, so we look at the degree of freedom. Okay, so this is very important to follow, since we have decided that the value at the top is by CHM and the value at the bottom denominator is by my developed method. Then we have to look at the samples by CHM. Okay, so here it is mentioned after 10 measurements, meaning that you have 10 observations, okay, for both, means that CHM also have 10, and my development method also based on 10 observations. Then the degree of freedom, okay, for CHM, because CHM is psi 1, okay, there's a lot of terms here, is n 10 minus 1. So this is the degree of freedom. And this is psi 2. Okay, so psi 2 is based on my developed method. And it seems that my samples also, my observation also 10. So I have the same degree of freedom, which is 9. Okay, so here 9 and the CHM method is also 9. So we have the value, what we call as F table from the table. Okay, 95% confidence level. Okay, and it is 3.179. Okay, so in F test, where we do comparison of the F calculated just now okay, is 2.25, the calculated one, and then compare with F from the table, okay, it is obvious from the value that F calculated is less than F from the table. So the next part is to do conclusion that there is no significant difference in terms of precision. So what does it mean? Is it good or bad? Anyone? Is it good or bad? Sorry?
It's good.
It's good. Meaning that your method, you develop yourself in the lab, and then you compare with standard method by an accredited lab, and then when you run F-test, there is no significant difference in terms of precision. Precision is data distribution, yeah, the precision. So it's good news. At least you've passed the first hurdle, which is the F-test. Okay, so this is number one, the easiest one. And then there is another example, but you can do it by yourself for the second one. Okay, this is all right. And then since we have time, before I'm going to discuss about your assignment, how are we going to divide you? So we move on to students' t-test. So t-test is now, we're talking about accuracy. Okay, just now is F-test on the precision of the data, how significant the distribution of the data, different from the standard method and the newly developed method. So the next one is the t-test. So this is the introduction. Students' t-test will give you how, in terms of accuracy, how good is your data with regards to the acceptable value. Sometimes it is named acceptable value, sometimes it is named reference value, true value. There are so many names. So now this is the easiest t-test. Why is it? It's missing in the middle. Okay, if possible, can you look at the module to check on the t-test formula? I don't know why it is missing in the. Okay, let me look at the PDF slides. Okay. Just a moment, yeah. Okay. This plus minus t. Okay, so the value of t is plus minus t, x bar. Okay, this is the simplest t-test. Okay, x bar means that mean. Okay. Okay, and then mu, known value, certified value, true value. Okay, means that it is the actual data that we are referring to, and S is standard deviation, N is number of samples. That one is quite general. So now this is the first t-test. T-test when the true value or the accepted value is known. Okay, how do you know that? For example, you receive a chemicals, okay, a chemical reagents, okay, and it is stated there it has purity of 70%. Let's say it is stated in the label at the bottle, 70%, and then you expect the true value should be 70%. So I'm giving very general example of listed value or known value. It is at the label of the bottle. Okay, so now you do the test. Okay, so again, this example is detecting arsenic in paddy. So you did 5 times measurements, means that the N is 5. Okay, and the result is found to be 10.8 plus 0.7 ppm. So the standard deviation is 0.7. Okay, and the result from old method, okay, in this case, the old method is called as mean of known value. Okay, it depends. Okay, so in question, you have to know which one is the accepted value, true value, known value. Okay, so it's not that difficult. So now we can just put in all the values that we have. Okay, so this is the mean. So it's 10.8 minus the known value. And then this is the N and the standard deviation. So this is what we call as T calculated. Okay, so the same process now we need to do, which is referring to the table. Okay, all right. So if you look at the table, so this is T table. And then the T table is, in this case, there is no decision whether we want to do 95% or 99%. So it's up to the question. If you are using 95%, let's say, and sorry, the degree of freedom is 5 minus 1, so 4. So now I cannot find 4. Okay. All right. All right, 2.776, okay? Because you are using 95% and the degree of freedom is 4, okay? So what you can do is the value from T is 2.776, T table 2.776, right? Correct. Okay. With comparison, T calculated 2.9 is greater than the T table 2.776. So now we know, or we can conclude, that the two methods are significantly different in terms of accuracy. Means that we are referring to the standard method, the old method. There is a significant difference. So what is the conclusion from this? Anyone? So what is the decision from this conclusion? We have the conclusion from the statistical test. Now, what should we do?
I should change the method.
We should change the method. Means that we need to repeat, right? Okay. So, okay, thank you. Anyone else wish to voice your opinion on this? What should we do? Okay, someone said, I didn't catch it, that we should change the method. Means that there is something wrong with your own developed method. So you need to like do some improvement, probably. Another way?
We increase the number of measurements, doctor?
Yeah, probably we can do that. We can do that as well. We can still use the same method, and then we need to repeat it. Okay. Yeah, there's so many things, but the most important is you cannot be happy with this result. means that there is something wrong that you need to improve. It's either you do have to do more tests, more samples, or you need to repeat back. You need to repeat back what you have done using the same samples or the new method that you don't improve anything, you just repeat back. Okay, so this is where the students' t-test is very important. So t-test, there are so many tests. So this is the first one that is very simple. So let's say you work as a quality control chemist, and then of course you receive raw materials for your production. Before you do production, you have to do some quality control of the received goods, right? You need to check, you need to get samples from the goods that you obtain. And as I mentioned, if the label says that it is 70% pure, somebody has to do some analysis to check whether the 70% claim is true. Okay, so the 70% will be the known value that you want to benchmark. Yeah, so that is the t-test, the first t-test. Now, the second one, which is the last one for today, okay. T-test to compare two sample means that at this moment, you don't know the true value. You don't know. Okay, this happens if you are comparing two different sets of measurements. Okay, just now, you already knew the acceptable value or the known value or the standard value. Okay, that is for the first t-test. For the second t-test, now you have different sets of measurement. Okay, if two samples have standard deviation, okay, this is an example. A new gravimetric method is developed for iron, in which the iron, okay, blah blah blah. You again develop a new method. The accuracy of the method, okay, is checked by analyzing the iron and comparing with the results using the standard precipitation with ammonia. So this is the standard method. Okay, and then this is your new method. Okay, and you want to make sure that your new method is comparable with the standard precipitation with ammonia. So this is the results. This is by the newly developed method. And this is your reference method, the precipitation with ammonia. You can see that their numbers of observation are not similar. They are not the same numbers. Okay, sorry. All right. Now, you do not have one value just like now, just like the previous one. You only have one value, acceptable value, 11.7. But instead, you have two different sets of data. So now, instead of just calculating the S, standard deviation, like the previous one, we have to use what we call as pool standard deviation. Okay, so what's the biggest difference between the pool standard deviation? We have to calculate. It's a bit, that's why we have to use spreadsheet or the Excel, okay, to calculate. When I studied before, actually we can use calculator to put in the value and get the standard deviation easily from the calculator, but I forgot how to use it. I mean, that was many years ago. So the best that we can do right now is to use spreadsheet. Yeah, spreadsheet is the Excel. Okay, but now is not the time. Now is to discuss the formula first. Okay, right. So this is the T formula. If you look at the first one, the T formula is quite easy. T is x bar minus mu true value, square root of n divided by s. So now we have two sets of data. You can see that we have the mean of the first set and the mean of the second set. And then we need to calculate the SP, pool standard deviation. And of course, N is from the number of observation, test method, and reference method. So we look at how we do it. Okay, we don't have to discuss this because if you can, usually because we do F test first before we proceed to T test. That's what common. So this is, if you do it manually, it's quite time consuming. You have to put everything. You can see this is the value of this table from here is the total of X, the observation minus the average, and then times the yeah, you have what? Okay, this one. So it's a lot of work. You have to times this. You have to do this table first and get the value. Okay, the total, which is 2.262, is obtained from here. The value of x bar minus observation minus x bar and then squared. The total value is 2.262. And then this is n minus 1. And this is from reference method. We have to do this by using Excel. And this one is the number of sample for set 1 and set 2 minus 2. Okay, finally, we get the pool standard deviation. And then we can put it inside the T formula. So 19.65 is the average from set 1. And then 19.24 from, I think it's from set 2. And then you have SP, pool standard deviation, and finally you get the T. So we're not going to do this manually, okay? We're going to do this by spreadsheet, please. Okay. So what we need to do next is to find this is the calculated T, right? So we need to find the tabulated T. So again, you can use the same table, T table, and then use the degree of freedom. Okay. So degree of freedom is number of observation from test method plus the number of observation reference method, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's 11 minus 2, 9. Okay. And if you look at the table, I don't know why it gets, so it should be 9, 95%. Okay. All right. 2.262. So it's 2.262. If you compare with calculated T table, means that T calculated is less than T from the table. Okay, so from here, the conclusion is at 95% confidence level, there is no significant or there is no statistical difference in the results by the two methods. So obviously, this is something positive. It means that the new developed method is comparable statistically in terms of accuracy to the standard method. Okay, so the challenge here is to do the calculation by using spreadsheet. The rest are just formulas. And I'm telling you, you don't have to memorize the formula. It's not going to be like examination that you have to memorize all the formulas. yeah, you did that during your undergraduates probably, but for postgraduates is a project based, means that you are given one question, you have to solve it by using spreadsheet. Okay, that will be the assignment will be. So no worry, you don't have to like, okay, I need to memorize things. No. Okay. Right. So there is one last, which I will not cover today. And now, okay, since we have everybody here, which is very important, is to divide you into groups. Okay. So what I will be doing, okay, let me stop the recording.